Thank you for attending today's seminar. So today I'm going to present a series of 3 studies that investigate environmental justice in communities through machine learning and advanced air pollution monitoring. So, transportation is a major source of air pollution, especially in urban environments. And when we talk about commute level exposure, basically we refer to air pollution levels that we are exposed to during our daily transit. And although probably we only spend maybe half hour per day, this kind of commute level exposure accounts for a large portion of our daily dose. So in terms of the health impacts, there are tons of epidemiology studies have demonstrated the strong associations between cardiovascular disease, respiratory disease, all kinds of disease that are related to traffic-related air pollution. And a recent study also found strong correlations with traffic-related air pollution with certain cancer types, like lung cancer and breast cancer here. And emerging research findings also highlight the disproportionate health impacts of traffic-related air pollution on vulnerable populations among us, like children and senior people. So here is a network of air pollution stations across Hong Kong. And I just derived this table from the most recent table that published by the government. So basically, the table tells us when we compare annual average concentrations that are measured in Hong Kong with the air quality guidelines. And we may find that all of them are either like 2 or 3 times higher than the values that are suggested by the guidelines. And for the roadside nitrogen dioxide, basically it is over 5 times higher. So, but today I'm going to walk you through 3 studies that are related to urban mobility and environmental justice. And all those studies are conducted in Toronto and Ontario. So the first study is basically about the application of machine learning and computer vision for predicting air pollution. And the second study, we incorporate another 2 dimensions, like social disadvantage and the mobility poverty, in order to come up with a community prioritization index to quantify triple burden of local residents. And in the last study is a 5 years campus community partnership for assessing and reducing air pollution in a local community that is very close to a city airport. So in those 3 studies, we focus on specific air pollutants, ultrafine particles. Why we care about this? Because these are particles that are at nano scale. Basically, it's very small compared to PM2.5 or PM10. And which means they can easily penetrate into our lungs, brains, and other organs. Not just like PM2.5, they will stay in our lung tract. But for the ultrafine particles, they can reach our brains. And however, those ambient ultrafine particles are not monitored by the regular or the air quality reference stations currently. And very recently, actually in this month, epidemiologists that we have been collaborating with, we published a study that found a strong correlation between ultrafine particle concentrations and brain cancer incidence. That's why I asked the question. Okay, and so in order to measure this kind of air pollutants, we use the Urban Scanner. This is a mobile monitoring platform that can measure air pollution, urban heat, local weather, and also we extract urban environments from camera and the LiDAR sensors in order to have a better understanding the situations that are around us. And the way that how we collect data is that we drive this Urban Scanner platform across streets, and we fine-tune the computer vision model to refine truck classifications. So basically I show here. And at the same time, we also get some public data from the regional air quality station, weather station. Eventually, we put them all into a machine learning model in order to make the prediction. And one of the major findings in this first study is that we find a strong correlation between single unit trucks and ultrafine particle spikes, which are basically the extremely high value of ultrafine particles. And single unit trucks basically are the common trucks that deliver large items like the furniture from the warehouse to the neighborhoods. And you may see that the spatial patterns are very similar across these 2 maps. And I'm not going to describe the details in this machine learning model output, but the idea is that only based on the publicly available data and features that are extracted from the images or the photos, as well as some temporal data, like time of day of the week, we can achieve model performance of 66% that can explain the variability in short-term exposure. And more importantly, in this model, we found a single unit track actually is a significant component, significant feature in explaining the exposures. And so in the second study, we develop long-term average air pollution exposure across the city, as shown here. This is the ultraviolet particle concentration maps. And some of you might be aware of that most of the cities that collect travel survey data, basically every 5 years or 10 years, basically they collect the transportation mode that you use during a typical day. From the morning all the way to night, what kind of cars you drive, or what kind of public transportation you use, or you bike or you walk to the destination. And so based on the air pollution map and those kind of travel patterns, we can get this estimation for the mobility weighted exposures, not just the exposures that where you live. And at the same time, if we get the socioeconomic data, we can conduct mobility justice and also environmental justice. So in this study, in order to get the socioeconomic features, we derive 4 different dimensions from marginalization index, which is published from the Public Health Ontario. So it covers residential stability, income level, proportion of senior people, children, and also the concentration of immigrants. And at the same time, we get the accessibility index from a website called Walk Score and through their API. So basically, we can quantify the accessibility index in terms of the walking, biking, or access to the public transportation infrastructure. So in terms of summary of these, of the main findings in this second study, we find that seniors have lower accessibility to those sustainable transport infrastructure compared to younger communities. And those who do not generate emissions are exposed to higher air pollution compared to those who travel in cars and who generate emissions. And lastly, we found that marginalized groups have fewer exposure benefits from working at home. And another very important findings is that we develop a community prioritization index incorporating air pollution exposure, social disadvantage, and also accessibility to transportation infrastructure. And the communities that are highlighted in red color are basically the one that we identified that should have prioritization in terms of urban planning and policy. And actually, the City of Toronto approached to us after finding this index, and they would like to incorporate into transportation inequity index in the future in the government report. And we also take some photos that in these identified communities. Basically, we found a lot of combination trucks or the regional trucks that provide freight services. And we found actually the spatial pattern of these communities are very similar to the distribution of combination trucks across the city. So in the last study, it's a 5-year campus and community partnership study. So it's not just about university and community. We also invite another 2 stakeholders, including the airport and the City of Toronto. So we invite everyone around the table and involved in this study. So the map here shows the BQA community. Basically, this is the local neighborhood, and you can see it is located along the lakeshore, and we can find the Toronto City Airport. Basically, it's just 500 meters away, this community neighborhood. They are just separated by a water channel. And during this 5-year project, we present findings to the residents, because during the pandemic period, most of them are online. So tell them what we found. So So the idea. So in this study, we did rooftop measurements across the neighborhoods. So over here, this is the neighborhoods, and this is the airport. Basically, they are in the south side of the neighborhood, and then there's another air quality reference station that is located on the south side of the airport. And we do measurements in the neighborhood, and also have indoor and outdoor monitoring using low-cost sensors. And so the main finding here is that we found that when the wind is predominantly from south, we found the ultraviolet particles doubled and tripled, and basically means that those are the impacts from the airport directly, because as shown here, the airport, So the airport is the only potential emission sources that are located on the south of the neighborhood. So basically, we find this significant increase. And besides from the mean values, we also look at time series plots. So here, the x-axis is the time, and the y-axis is the ultraviolet particle concentration. So the black dots represent a typical ultraviolet particle level on a busy road in downtown Toronto. And if we superpose them using the concentration that we measured in the neighborhood, that's shown in the blue color and the red color, you may find that we may sometimes they have high correlation, but most of the time they have all those kind of spikes, like ultraviolet spikes. And so another finding in this study is that we find that disproportionate impact of those smaller aircraft on those spikes. So because initially we considered that probably the larger commercial aircraft, as shown here, that provide regional services, transit services, they are not the one that are the dominant, sources of generating those ultraviolet spikes. And the reason why those smaller aircraft can generate these spikes because they are operated by flight school or which means they are not regulated. They use very old engines. So that's the main reason why they emit much higher ultraviolet particle spikes compared to commercial flight. So the last and the most important component of this study is that actually at the beginning of this year, in January, we hosted a workshop to disseminate our finding results, and it attracted like 70 participants to attend, including. So after we present the results, we invite the stakeholders, including City of Toronto, Toronto Public Health, airport representative, and also local resident representative. To put them, and then invite them on stage and have a discussion, and hopefully we can lodge planning or policies regarding land use, transportation, and airport operations. And we also have some group discussions, and also ask the local residents to put in their ideas and what they have learned in this study. And basically, this is the end of today's presentation. And I also put a QR code here that have more detailed or comprehensive findings. Because this is a great opportunity for fostering, collaborative, projects. I also list the other studies that I have been leading related to simulation, modeling for scenario analysis. I also do a lot of GPS tracking, driving behavior, and also involved in study that use commuting surveys and carbon literacy. So probably after seminar we can also have further discussion. So, thank you.